Data is essentially vulnerable the moment it starts to move. While it's at rest, it's being under the protection of the platform and the systems, but the moment it actually goes out of that platform, and it starts to become more vulnerable and susceptible to cyber attacks. As an industry, we have been very focused on securing data at rest, putting the chains and the locks around the platform, building bigger walls. That has been kind of more of the notion. I think it's flabbergasting that data encryption at rest is still considered to be one of the acceptable measures and a compliance checkbox that we click on every day, and the auditors are happy about it. I think if I had $1 for every time someone mentioned about their data security posture, that our data is encrypted at rest and our data is encrypted in transit, then I think probably I wouldn't have to go into a fundraising mode, right? We'd probably be already bootstrapped and self-sufficient in that case. So I think when it comes to these in-transit traffic, people are reliant on TLS. And of course, the whole point about TLS is, from a point to point, where you're keeping a secure tunnel that essentially having the man-in-the-middle attack negated. But oops, quantum came over, right? And then Shor's algorithm broke most of the RSAs and ECDSAs, and this whole concept and fear about harvest now, decrypt later popped up. Application layer encryption and tokenization. That's kind of probably the highest level of data protection that you get, where you persistently protect data the moment it gets collected at the application layer before you write that into a database, upload that into a cloud data warehouse, or send it to a third party. But the challenge with application level encryption and tokenization is that it's time consuming, it's very invasive, it's complicated. And there are a lot of tools out there who provide you with SDKs, APIs, and client libraries for encryption tokenization. But on an each application basis, you got to make sure that they are redesigned to incorporate those encryption libraries, incorporate those SDKs and APIs, make those function calls, change the code, redeploy, test, and go through 6 to 9 months of cycle. And that typically what starts as a very good intent, it doesn't scale, and the adoption starts to drop. And I've kind of lived that life across multiple enterprises trying to do that, but obviously the business didn't move beyond a certain point and the writing was on the wall. Then we started to kind of put compensating controls, try to reduce the risk. So what really happens is, in this phrase of data protection by design, it basically becomes data protection by redesign. Because now you're taking existing application and redesigning them to bake data protection in. In an enterprise, basically depending on how many applications you have on an average, it's a 3 to 4 years of engineering cycle that you spend tens of millions of dollars, and not just from a CapEx standpoint, but even from an OpEx, as you have upgrades or patches to encryption libraries or changes to existing data structure, you go and keep changing your applications and redeploy and go through the same cycle. So from an OpEx standpoint, it actually becomes very expensive as well. Enter AI, generative, agentic. And in that case, you hardly have a human in the loop. Applications talking to large language models, standardized protocols like MCP, A2A are just making it much easier for agents to interact with each other. Unfettered access to multiple data sources to actually perform a function. How do you bake an agent with encryption libraries and have the agents get recoded in terms of that? It's not a starting point anyways. So the results, a lot of investments into putting in all of these disparate, fragmented tools, or trying to do the right thing, but in the very legacy way. And at the end of the day, your risk reduction has been very minimal. So the risk funnel typically now looks like a cylinder, because when you started with the inherent risk, no matter how much security controls you put in, your residual risk never really gotten smaller like a funnel. And lo and behold, during that whole time, you've been breached, and then the cycle of investments still going on, because now you have to recover from the breach. You got to respond to the breach. So I guess the whole point of this session is that we got to throw the playbook, the old playbook that we've been using, and start writing a new one. Okay, what does that new playbook need to look like? So first of all, I think we need to kind of create this whole paradigm of crossing the chasm. How do we get from insights to action in a more runtime and automated fashion, right? So that's the first thing that we got to do. Visibility alone is not protection. So we got to tie visibility and persistent protection together. And only that way you are able to, at runtime, get visibility and insights of what's flowing across your network, and then ability to very seamlessly navigate towards protection in the same flow. So as data is flowing in, whether it's PII, PCI, PHI, the runtime data insights and protection, which is the new model in this case, data is not only being just detected and classified and surfaced that what exactly is being flowing across your different pipelines, but as per the policy, you could essentially select which data elements you need to protect, whether it's through AES 256 encryption or format preserving encryption, SHA-256 hashing, masking, regardless of what obfuscation mechanism you use. The other thing is that you got to make this automated. There's a phrase, if it's not automated, it's broken. It kind of applies to that. And the moment you have more manual work, application redesign, and then configurations and deployments and all that stuff, or putting these different DLP endpoints, and then you're going to miss something, right? So the whole thing has to get automated and has to be encapsulated, the whole business function around it. Next thing is that we got to pivot from this static point-in-time thing to more of a runtime and continuous model. And the biggest thing is you have to make this frictionless. Right, the moment you are asking the business development teams to go and redesign apps, install libraries, redeploy, take an outage and disrupt the whole service, that's where adoption will stall. So let's rethink: are you runtime or are you running behind? Right, because when I say running behind is like, are you chasing alerts or you're taking action